Hello, in this presentation we'd like to show you how we're going to go about modelling a stair with two flights and a different glass rail on each side of that stair, also with some support structure. So the first thing to do is to start a blank file and assign some basic project information to identify our model. It's a simple dialog box to enter the information you need and some simple properties. These properties will show up again later on the drawing title blocks and building materials headers. Now we're ready to start modelling, so we'll put in our straight stair using our macro for a straight stair and simply enter a couple of 3D coordinates for the bottom and top of the nosing line, since we have nothing else in our model yet to snap to. In a few seconds a first flight of stairs is created for us, and everything about this is controlled from our dialog box. So as you can see, by default we've got channels for the stringers, pieces of grating for the treads with end plates bolted to the stringer. Within the macro you can change everything about the overall size, the stringer section, the treads are spaced out using the 2R plus G formula, and we have 24 different styles of tread we can use. With each type of tread we have a full range of options and properties we can adjust. So if I change to one of the other styles here, you can see how it's immediately updated in our macro. Perhaps I'll decide to have it welded to the bracket underneath so there's no bolts there. And now we can change the size of that tread to make sure they overlap with each other according to the rise and going of each individual stair, just like so, and everything updates live. We can also have a different unique top and bottom tread as required, or can add landings to the top and bottom of our stair like this one that we have at the moment. And again, with the landing you can choose everything about the cover and the sections supporting that landing. Now, rather than remember all the many options you might set, each company probably has a standard or a preference, and you can store that in the joint library. So if I just select a different entry in the library here, it's like sample 4, the whole stair reconfigures immediately to those settings that I've stored previously. You can see we have folded treads overlapping at the front of each tread, and the bottom tread is actually different front lip to make it longer and reach the floor, and we also have them bolted to the brackets underneath with countersunk screws, and the brackets are welded to the stringer. There's front lip on that bottom tread is all the way to the floor, so there's no unsightly gap. So for the second flight we simply need to copy that stair we have using the options available. Using standard CAD snaps, we copy from one end of the existing stair to the top. And there we have our second flight with the same properties. Now, to make those meet up and match nicely, just make some small adjustments. So on the lower tread, lower stair, we're going to adjust that landing. Make the cover plate longer so it extends to meet the bottom tread of the second stair flight, like so. Now we'll go and miter these stringers together so that they have a neat join between them. Same front and back. At the bottom of the first flight we have standard joints that can handle the bottom of stairs appropriately. So I'll just select the joint from our vault and the stringer to apply it to, and this will add an angle bracket for foundation bolt. But what we'd actually like to do is add in a small vertical section to make a much neater joint. We need to adjust the parameters or sizes of that so that it lines up with the first tread in the stair. You can use this offset to enter a thickness of some screed if you wish, and we'd like the anchor angle to be on the inside of the tread, so I'll just flip that over with this option. So you can see there, the angle is now on the inside of the tread. Now we can use our tools to copy this joint to the other stringer with the same parameters. Now obviously it does have the same parameters, so the angle is still on the right, and we need to change it to the left. So just a quick edit. And that angle is now on the inside of the stringer. So we have a nice neat foot on the base of our stair. That completes our stair. Very simple with our macros. Now I'd like to start adding a freestanding glass rail to the left hand side of that stair. So just rotate to a nice orientation. And with these glass rails you very often have some custom sections and channels made where you have a special section and a wedge to hold the glass in that section. So these have been defined. Rather than drawing two beams at once, we can draw both of them in one move using our compound beam tool, where I've already configured this to have the typical example of a Q-rail easy glass channel, and there's the channel with the wedge already in the correct position, all as though they're one piece. If I change the presentation to exact, you can see there that it's got all the detail of the shape of that section in there, but most of the time we don't need to see it in that complexity. And we have the two sections identified in that list. So I'll just change back to the standard presentation and we can carry on working with that. So I'll just run a piece of this section along each of the stringers. Just use the standard CAD snap points again to lock onto the locations we need. And that completes our 4 base beams. Once we've selected this one. Now for the handrails, we'll copy those base beams up and change the options or the properties. So I'll just use a simple copy command. And we'll start with the ones on the landing, because on the horizontal they'll be at a different height on the slope. So I'll make those 1100 higher for the handrails on the landings. And then we'll copy the sloping rail 900 up, like so. Now we can change the properties of these beams to change them to the appropriate beams for the top of the handrail rather than the base channel. Just go into each one and select the correct beam type. Again, this is one of our custom sections where we have the wedge for the top as well as the special tube section. So any custom sections can be added to our system if they're not part of the international library that's already included. Now to bridge those gaps where the height changes, we'll put a small vertical section in. Just change the orientation and the position so it's correctly in the model. Now we need to miter these beams together to make a neat joint between them. So we'll go back to our standard miter command. And apply it to each pair of beams in sequence. And when this is applied to a compound beam, each individual beam in that set is mitered appropriately. So the wedge and the main beam are both being mitered correctly. Like so. Now down the bottom of the stair we still have the front of these special beams at the slope of the stair, and we'd like to make those end vertically. So what I can do, I can put my coordinates on the end of the stair to define the place we'd like to cut, and then ask the system to cut the beams to that plane, thus creating a nice vertical end on these sections. Now actually these top beams need to be moved across a little bit because the plane the glass goes in is a little offset between the two beams, so just move them the appropriate amount across, like so. And they're now in the correct position, so the glass is all in one plane. So the next move is to start creating some glass infill panels. So I'll tell it which plane I want to draw the glass on by moving my coordinates. And I can use this tool for 2D snaps. That means that whatever points I snap to will always be on this plane, rather than just drifting off the plane and trying to draw confused plates. So now I can work in the side view comfortably, knowing that I'm always picking the right depth. I can start drawing the plate simply using a polygon plate tool, and I can draw it quite large. I can draw the whole stair as one piece, and I'll cut it into individual sections later. The endpoint snap will be easier to use for locking onto the right locations. I'll lock onto the bottom of the groove in each member. Just follow the shape of the railing around. You can see I'm getting a ghost as I go to show the shape of the plate joining up to the start point. When I get to the last position, I simply accept that and I have my plate. Give it some basic properties, don't forget to tell it it's glass. You can change the thickness and position if you need to. Which side of the line or the plane do you want the plate on? Just double check, yep, that's in the right position. And you've got a nice plate going into the grooves that mount the glass. Just for cosmetics, I think I'll change that plate to be cyan colour. That makes it look a bit more like glass, and I can recognise the difference between that and other plates. Now what I'm going to do is divide the plate into sections, and I'd like to be able to use some construction points for that, so I can divide the sloping portion into 3 equal sections, and this command will divide that sloping handrail beam into 3 equal length pieces, or however many pieces I wish, and mark those positions with nodes. So I'll do that for each of the sloping sections. And now I can use those nodes and the corners of the plate as positions to cut from. So I can use the various commands we have to split the plate up into separate sections. I'd like to add a gap of 10mm between each pair of plates, so set that option, and now I can choose the point I want to cut at to divide the plate up. So I do that once for each cut. Lock onto the nodes I just created with the divide tool. If I rotate a little bit, you can see the cuts better that way. Continue that down the length of the stair. So this will give us 3 equal size, equal shape sections of plate down the sloping portions, and then the landing ones will be unique. So in principle that completes the rail for the left hand side. You would obviously put a few fixings in to mount the bottom groove channel onto the stringer, but that's essentially what's involved. Let's see what we have then so far. Now we're ready to start modelling a rail up to the right hand side of the stair with infill panels, but before I do that, let's turn off some of the settings we used for the left hand side. Now I'm going to base the right hand rail on a standard piece of railing but using infill panels, so we can create the standard portions of the railing using our railing macro. First of all, you just choose the beams you want to follow with the rail and start at the bottom, end at the top. Now the railing macro is extremely powerful. It starts off creating a default rail, with in this case a fairly industrial looking one, but just as with the stairs we can change anything you can imagine. So we can change the post section and the post spacing and alignment. Lots of options about spacings and how the posts connect to each individual member of the railings. The top handrail, again, you can change the section. You can have different heights on the stair and on the slope, on the horizontal. You can have different middle rails, any number of middle rails spaced how you wish. You can have balusters spaced however you wish, and any sections you want. Same for kick plates. And you can put on special end treatments for the rail, so perhaps I'll show you one of those. Don't want the sharp ends, you can change it to loop and you get a nice closed loop on the end of your rail instead. You can choose various choices of how the posts are connected to the stringers that support them, and if you want to, you can even turn on a grab rail or hang off rail. Let's show you one of those. There you go. Very simple to do, and there's various options to go with all of these members. Again, there's many options there, so rather than have to remember all those options, you can store your preferences in a library, and we have a few in there already. Let's have a look at what some of those are like. There you go. That completely changes the whole configuration as soon as you click on it. This one has lots of flat middle rails, and he has a kick plate on the horizontal. This rail is quite different. It's got a different mounting arrangement off the side of the stringer, and it's got many middle lines. Now for glass, I'm going to choose a very simple configuration that has no middle rails, just the posts and the top rail, and that gives me the openings I want to put the glass into. Now to clarify what I'm doing with the rest of it, I think I'll just select this rail and hide everything else. So we have a tool for that. Like so. Now I can see clearly what I'm playing with and working on. So I'm going to start drawing a glass panel between those posts. I've just put my coordinates in the right position to tell it where the glass goes. First of all, I'm going to bring in some clamps for the gripping the glass. Now, the recommended way to do this is to prepare some typical examples in advance, like we've done here. Just one post with a few clamps on, and I can just copy and paste that example now into my model using a standard clipboard. Copy. Don't need that file anymore, and then in my main model I just paste that in, and I don't have to make all the joints individually again, because now it's in my main model. I can just use our various copying tools within the model to move that around. Now, to help me get the right snap points and lock onto the right positions, sometimes it's a little easier in wireframe mode because you can see through things. So I'm going to copy those clamps with their bolts and everything, and I'm going to use the top of the post as my reference point. So I've switched to 2D wireframe mode just to make it a little easier to see what's going on. We have the tools to display in various ways depending on the operation you're doing and your personal preference. You can choose different display methods. So I'm copying these clamps to every post, and it's drilling the holes in each post as I go. So the screws and the hole positions and everything are taken care of for me. Now it's easier to copy them in a group of 4, but I don't need these end ones, so I'll just go back and delete those extra ones. And of course the holes in the posts are deleted with them, so you don't get stray holes. Same at the bottom. Don't need that sample anymore. So I've now got all my glass clamps up the rail in the right positions very quickly and easily. So now I'll draw my first panel, and I can use just a polygon plate like we did for the other side of the stair. And we can use the nodes that are on the rail posts as the corners of that plate to get the basic shape. Now I don't actually want the plate to overlap with the posts, of course, so make sure it's in the middle of that depth. I can use the grips on each plate just to move the edges of the plate in by a given offset, so maybe 50 on either side and 100 top and bottom. So that's my first plate for the first slope. I can do the landing plate, then I know that's going to be rectangular, so I can make that slightly easier and use the rectangular plate. Being rectangular, I can actually round off those dimensions in the dialog box and adjust the overall size as well to make the offsets for me, because it'll always adjust around the centre of the plate. So that's my landing plate there, correctly done. Now the top flight has one extra tread compared to the bottom flight because the stringer goes that bit further, so the infill will be slightly bigger. So I'll just draw one for the top flight. And create the offsets again like before. Okay, now we need one last one for the top landing. Again, I can just do a rectangular plate for this. Round off those dimensions. Okay, they're done. So I'll copy up the shaped panels into the other positions along each flight using a standard copy command. Slipped up there, one extra one, don't need that, delete that. Copy the lower flight. Great. Now I need to connect these plates to the assembly so that when I do a nice assembly drawing later, the plates are included, and I'll just tell it they're all connected up by basically creating a dummy weld. Like so. So that's told the system that these all belong together. And now I'm going to just change them to cyan, so again I can recognise clearly that they're glass rather than a steel plate. Make sure I sign the material properly. Yep, that was good. Okay, go back to shaded display mode. There's my finished rail. And now turn on everything else back so we can see the whole stair. Like so. Just clean up some of these extra boxes that we don't need to see now. Lovely. Okay, so now it's time to add some support structure to our stair. First thing we need to do is put some beams across underneath this top landing to mount it from. So let's adjust the view. And now I can draw in some beams underneath there. Whenever you draw individual beams, you have the full range of global standards to choose from, shape and size, like so. We can also choose a position. I don't want the beam oriented like that, so I can use these toggles to rearrange the position of the beam relative to the points I just chose. Do another beam across the other corners. And position that one correctly as well. Okay. So I'm going to create some construction lines for the position of my next members. Nothing overly fancy, just a rectangle across the corners here. I'll put that on the construction layer so we can hide it and get rid of it later. Now what I'd like to do is offset that by 75 so that we can create our supporting legs a fixed offset from each corner. So that's that one done. Now I need to find the position for the bottom of the legs as well, so I'm going to copy that down to the length I want the legs to be done. I'm going to go downwards 2.5 meters. And now I'll construct a couple of points to put the bottom of my legs on. Put those elements on the construction layer too. Now I can easily snap to those points to place my columns or legs. I'm going to use tubes for these. Just choose a different size. Make sure it's in the centre. We should also tell each member what part it plays within the structure to get nice accurate names and drawings later. So I want 4 legs in total. Okay. So at the top of the leg, I need to bolt the leg to the support beam. I think a simple end plate joint will do nicely for that. Standard joint takes into account all the compound angles and miters. Just needs a little bit of adjustment on the offsets and maybe the bolts. I think a bit smaller than that be okay. Just check that. Get that to move across the middle. Okay, that looks good. So having got one joint now, how I like it, I can use our standard copying tools to copy the whole joint with that configuration I've just created to multiple locations. So at the top of those 3 legs, just like that. And there you go. Got the 3 new joints added in. Taking into account the angles and miters in each position correctly. Those 2 beams need to be welded onto the stair. So just tell it to do that. Like so. So that's the top done. Now at the bottom we need to put some kind of base on there. I'll use a circular plate. I think 600 should do. Yep, that's nice. Let's double check we got it on the right side of the line. That's the side I wanted. Now we'll cut the bottom of the tubes off to that plate. So cut each tube in turn and it deals with the angles for you. Hide those green symbols, don't need to see them anymore. And we can turn off the construction since we're finished with that now. Still up in fresh air though, so maybe we need a concrete column underneath that. So I'll just ask for a concrete member, start in the centre there, down to floor level. Now tell it the shape. You can choose any size you like for concrete, not fixed to a list. And of course get the position right as well. There you go. Now having created one structure to support, I can copy the whole support structure from the top landing using one key point down to the middle landing using a corresponding key point. I don't have to select every individual member meticulously because the system's clever enough to find those joints and copy them for me as well. So immediately you can see I've got the full lower support structure done. okay to me. All I need to do is make this leg shorter, so I just use the grip to adjust the length of the leg, like so. And there's our nice finished stair. In fact, looking at that, I don't think I put any anchor bolts on, so what we should do is go back to those base plates and just add some anchors. So just say I want to drill an anchor through there. I'll have a circular pattern of anchors centered on this point. And there you go. We have a full range of different anchor types, so I think I'll go for hill tube anchors in this case. That's much better now. It's firmly fixed to the concrete. And we'll do something similar here. Like so. So the next step then is to start creating some documentation for this structure. So before we can do any documentation, we number the model, and that makes the system work out all the identical parts and give them numbers and types, so that we can create the full documentation. Now, to create our overall views, we can use a system called cameras. So what I'm going to do is just create a camera here for each side of the stair, and set some properties for what I want to look at. So I want to look at the front only, and I'm going to use a simple overall style. I'll do the same for a view from the other direction. And I'd like to have some nice isometric or 3D views on my drawing, so I'm just going to set one view to look from this direction currently, and I'll put a camera to call up that view. And I think I'd like a view from the back looking up at the support a little bit, so let's rotate to a nice angle, something like that. And I'll create a camera for a view from this direction. Okay, so now we have the GA views we wish to have shown drawings, define them. We can now use a simple overall process called Process Suite to draw everything. This will draw all the cameras that you've asked for, plus all the assemblies and all the parts. So I'll take the system a moment or two to do that. You can see it's flashing by, creating lots of drawings. You might notice that it's trying different scales for the views, different sizes of paper to find the best fit combination. Each drawing will be fully dimensioned and fully labelled up as requested. So it's doing all the hard work for us in just a few moments. All the drawings created remain fully intelligent and linked back to the model. Okay, let's finish that now. Let's have a look. We have a tool called Document Manager that controls the files once they exist. So if I go into that tool and have a look, see, there you go, lots of drawings created. And here's a few samples. You get a live sample on the screen. So there's one of the lower flights of stairs, there's the top flight. You had the legs structure a minute ago. Here's one of the parts for the hand railing, one of the plates. You can see each individual part is fully dimensioned with all the required manufacturing information. There's one of the treads for the stair. You get a flat pattern as well as a folded tread there. Here's the support beam underneath the landing. And even on a complicated thing like a railing, it does a very good job of drawing that for you entirely automatically. You can see it's got the special glass clamps there and the glass panels. The only thing is, maybe it's got a little bit carried away with the labelling, so we don't need to label each clamp individually. I'll just go around. I think we'll select these and delete all the extra ones. And maybe combine these into one label. Oh, don't want to delete the dimension. So I'll just take a few moments to clean up these labels, because obviously on a assembly that's pretty complicated like this one, it's difficult for the automatic rules to get everything perfect. Just two left, and I'm going to keep this end one, and I think I'll just change that text, move it to a nicer location so the arrow's not going across my part. Add in an extra comment that applies to all positions, so just say typical there. And that's sufficient, and then you can see the dimensions clearer. You can see that actually they're very good dimensions for the assembling that rail. We also have a bill of materials on each corner of the assembly drawings there. So we can save and close that drawing. Have a look at our GA now. There you go. Now with the GA, it's automatically chosen some scales for us, and in this case the first view was quite large and the others were a bit small, so we want to make them all the same scale. So I can simply click on this outer box for the properties and select any desired scale I want, and everything's redone for me in a short moment. Very easy to do. We can rearrange those views on the sheet of paper just by dragging them to the desired location, or I can use the move command so that I can actually use the tracking and snap points to make sure they line up properly, like so. Okay, that's quite good. Now you can see there it's put some weld symbols on the views. Now they are site welds, so they should be on the GA views really, but we don't particularly want them on this drawing, so I was just going to select them all en masse and delete them. And now what I'd like to do is add in a shaded effect for the two isometric views. So we start off by referencing in our actual 3D model. There it is. And we can match our coordinates to the cameras that were created in the original model. And store that position so we can call it up later. Same for the back one. Let's change back to a shaded display to look better. That's nicer. Now, to help me position the shaded views with the line views, I'll just add a simple line in here that I can use for reference. Okay, back to paper space. And now I can call up a view of that shaded model. Just put it in a box out the way for a moment. And then I orient it correctly as required to match one of my existing views. And go into the properties and select the required scale, which was 1:50. Now we'll set that to be a shaded view. Like that. And we don't really want the cameras in that view, so we can turn off the camera layer as well. Now I'd like to move the view, so we can select the viewport and use the move command. And this is where the reference line I put in comes handy. You can line up the end of that. To the corresponding point on my line view. There we have two nicely aligned views, giving the shading and the outlines together. So we can repeat that process, creating the viewport and setting it up and moving it for the other isometric view as well. Now we have our two views nicely aligned. We don't really need that reference line anymore, it's done its job, so I can delete that so we don't get that showing up on any prints. We can add dimensions to our views. As we say, the models and the views are all related and linked together, so I'll just ask for some dimensioning. I can choose any points I wish, and I'll get the true dimension from the model. Let's add a vertical dimension as well. Very simple. I think I'll just move the edge of this view in so it's not outside the drawing border. And then I can go ahead and print this nice GA view to a PDF file. So I'll just go ahead and open up that PDF from disk. Have a look at it. There you go. Nicely shaded views. With the outlines drawn on as well. And of course our side views with the dimensions we placed. So that's the drawings done. What we'd like to do now is create some lists. So they're created easily as well, using this tool called Quick Documents. You choose the type of list you want, and then simply click Use. And the information will be generated and displayed to you. So you can see on this bill of materials it's grouped by section size. We have the custom easy glass sections listed there, each member at its length. We also have all the glass infill panels and the special glass clamps that we called up as well. So everything's there with its proper names, and we can export this list to PDF or to Excel or Word documents as well. So we can share that with other people. So there you have a complete stair structure with drawings and lists. So thank you for your attention. If you have any questions or would like further information, please don't hesitate to contact us.